This video lecture is meant to cover the information found in Unit 8, Section 4, Stoichiometry of Equations. And in this section, it's really presented to you in two parts. The first part is a very simple mole-to-mole stoichiometry, and the second part is a more advanced stoichiometry that involves the use of mole-to-mole stoichiometry. So this section builds on itself as we go through the section. So I'm going to start with the first set of problems, which is mole-to-mole stoichiometry. Here we have a balanced equation where we have nitrogen gas reacting with hydrogen gas, and it's making ammonia. Now, we see here that the coefficients, there's an assumed 1 here, in a balanced equation represent moles of each substance. So if we had 1 mole of nitrogen gas, we would need 3 moles of hydrogen gas, and it would make 2 moles of ammonia gas. So what's kind of cool is that's sort of like a recipe. If instead of 2 moles of ammonia, let's say you wanted to make 4 moles of ammonia, well then you would need 6 moles of hydrogen and 2 moles of hydrogen. So we're going to use that those coefficients to help us. The coefficients will therefore be used as a mole ratio in the form of a conversion fraction, that 1 to 3 to 2 for this particular equation. And this is really useful when you're given a number of moles of one substance and you're being asked to find the number of moles of a different substance. So for example, if you had, instead of 1 mole of nitrogen, let's say you had, I don't know, let's say 3 moles of nitrogen instead of 1. So instead you would need 9 moles to make 6 moles. So we're going to use that in a more formalized manner here in the next few problems. So for this reaction, nitrogen plus hydrogen turning into ammonia, how many moles of NH3, so this is what we're trying to find, moles of NH3, will be formed if 6 moles of N2 are completely reacted with hydrogen. So what we're going to do is, like any conversion problem, that's really how you approach this, you're going to start with the moles given to you, the number given to you. So that's 6.0, and I'm using a new drawing tablet, so excuse my handwriting here. 6.0 moles of N2. Laughing at my handwriting with this tablet, it's really goofy. All right, so in any conversion problem, we need to set up a conversion fraction where we're immediately going to put the unit that we were given in the denominator of this fraction, and that unit that we're trying to get rid of is moles of N2. What we're trying to get to is moles of NH3, so I'm going to put that up here, moles of NH3. Now the numbers that go into this fraction, the numerator and the denominator, come from the coefficients of the balanced equation. So there's a 2 in front of the NH3, so I'm going to put a 2 there. And there is a 1 in front of this nitrogen, so, lost control of my cursor there. There's a 1 in front of the nitrogen, so that's what's going to go there. So what we can see here is that moles of N2 will cancel, and the math just becomes 6.0 times 2 to give us 12 moles of NH3. Okay. Let's take a look at the next problem. How many moles of H2 are needed to completely react with nitrogen, N2, to form 1,000 moles of NH3? So what we see here is we're given this quantity, 1,000 moles of NH3, and we are being asked to find how many moles of H2. So that's what we're trying to get to. So we're going to need this coefficient, and we're going to need this coefficient. We're not going to do anything with nitrogen for this problem. So we're given 1,000 moles of NH3, and we're going to set up a conversion fraction. Immediately we're going to put moles of NH3 in the denominator, and in the numerator we're going to put moles of H2. So the coefficient in front of the hydrogen from the equation is 3, and in front of the ammonia is a 2. So here we're going to see that moles of NH3 are going to cancel, and the math then becomes 1,000 times 3 divided by 2, which is going to give us 1,500 moles of H2. In terms of significant figures, the 3 and the 2 are exact counts, so they are not measurements. We are not going to let the coefficients limit us, so we're limited to our 4 significant figures here, which is what we have over here is 4 significant figures. Now I'm just making stray marks everywhere. Okay, but that's our answer for that particular one. All right, so now we're going to move it into advanced stoichiometry. We're going to build on this mole-to-mole stoichiometry, and this is where we're not just going to be converting between moles to moles of different substances. So we're going to need to know that 1 mole of any gas at STP conditions will have a volume of 22.4 liters. You might need to know that 1 mole is equal to 6.02 times 10 to the 23 molecules. Or you might need to know that 1 mole is equal to the molar mass of a compound, which is where you go and add up the masses on the periodic table, rounded to the nearest tenth. So here we have a balanced equation, and now take a look at what we are being given here. We are being asked to find how many grams of zinc are, so my pen is going out of crazy here. We're trying to find grams of zinc are needed to produce 20 grams of zinc chloride. Okay, so now instead of being given moles, we're dealing with grams. So we have a quantity of the zinc chloride, and what we're trying to find is grams of this substance over here. So we're not going to need to know anything about the HCl or the H2. They're just kind of there for the balanced equation, but they're not important to this particular problem. All right, so these problems are really just big conversion problems. So we just always start with the number, the measurement given to us, which is 20.0 grams of zinc chloride, ZnCl2. Okay. Well, here's the problem. What we know is that 1 mole of zinc will produce 1 mole of zinc chloride. But we're given grams. So to go grams to grams, that's not a 1-to-1 ratio. These coefficients do not represent grams. So what we're going to need to do is convert grams of zinc chloride into moles of zinc chloride. Then we're going to convert moles of zinc chloride into moles of zinc. And then we're going to take moles of zinc and convert it into grams. So this kind of problem where we're going from grams of one substance to grams of another substance, that's going to be 3 conversion fractions. So what we're going to do is we're going to set up our first conversion fraction where grams of zinc chloride is going to go into the denominator. Right, so this first fraction we're going to convert grams of zinc chloride to moles of zinc chloride. And this is a molar mass, right? So 1 mole of zinc chloride weighs how many grams? So we're going to have to go to our periodic table and figure out what that molar mass is. From the periodic table we add up zinc and 2 chlorines and we find that the molar mass is 136.4 grams. Okay, so this first fraction, if we stop here, we see that grams of zinc chloride will cancel with grams of zinc chloride. It would leave us in a unit of moles of zinc chloride, which is not quite where we want to be. So now we're going to set up a second fraction, and this fraction we're going to get rid of the units of moles of zinc chloride. And now here's where we're going to use that handy mole-to-mole ratio trick that we just learned. So moles of zinc chloride to moles of zinc is going to be the function of this fraction. And so here we see that the ratio is 1-to-1. So those are the numbers we fill in. If we stop here, we see that moles of zinc chloride cancel with moles of zinc chloride, leaving us with moles of zinc. Well, we're almost there. We know moles of zinc if we do the math here. We just want to convert it to grams. So one more conversion fraction. And what we're going to do is put moles of zinc in the denominator and grams of zinc, that's a G, grams of zinc in the numerator. 1 mole of zinc, according to the periodic table, weighs 65.4 grams. And if we allow the units to cancel, moles of zinc will disappear. And now we're left with the unit of grams of zinc. So the math in your calculator is 20 times 65.4, and we need to divide that by 136.4, and we get a number that is rounded to, let's see, probably 3 sig figs, 9.59, yeah, that's right, grams of zinc. And once again, I apologize for my spastic pen, learning to use a new drawing tablet here. So for this problem, it says how many grams of HCl are needed to produce 20 liters of 20.0 liters of H2 at STP. So STP conditions. So if you are given a volume of a gas at non-STP conditions, you're going to have to solve for moles of the gas using PV equals nRT. But okay, so that's not the situation right here. We are at STP, and so we just continue on with the problem approaching it the same way. We know that we are given 20.0 liters of H2. We know what we're trying to find is grams of HCl. So the first thing we're going to have to do is convert liters of H2 into moles of H2. So let's get rid of that liters of H2 unit, and we're going to convert it to moles of H2. We know that 1 mole of any gas at STP is 22.4 liters. All right, well, if we leave the problem here, liters of H2 will cancel, leaving us with moles of H2. But what we want is grams of HCl. So we now have to convert moles of H2 into moles of HCl. All right, so we're going to get rid of moles of H2 by putting it here in this denominator. And we are going to go to moles of HCl in the numerator. So the coefficient in front of the HCl from the balanced equation is 2. And the coefficient in front of the H2 is a 1. So now if we let the units work themselves out, moles of H2 will cancel with moles of H2, leaving us with moles of HCl. But we want to be in grams of HCl, so we are going to need to put moles of HCl down here in the denominator to cancel out with this, to grams of HCl. 1 mole of HCl, according to the periodic table, 35.5 plus 1 is going to give us 36.5. So moles of HCl will cancel. And now we just have to do the math in our calculator. So what we have here is we're going to take 20 and we're going to divide by 22.4. We're going to multiply by 2, and we're then going to multiply by 36.5. Our answer works out to, let's see, we're going to go to 3 sig figs. It's going to be 65.2, and the unit is grams of HCl. So there is our answer for that particular problem. So I made a brief reference to what about gas problems where the conditions are not STP. And so in this particular situation, you would have to use the ideal gas law to convert between the volume and the number of moles to help you figure out when you have a pressure that is not standard pressure and when you have a temperature that is not standard temperature. So just remember when you're using the ideal gas law, a couple things to remember. Temperature has to go in as Kelvin, and R is the universal gas constant at 0.0821 atmospheres times liters all over moles times Kelvin. So it's kind of an odd, awkward unit, but it's very helpful in the fact that it cancels out all the other units there. All right, so as you continue on with these stoichiometry problems, just remember, let the units do the work for you. The whole job of setting up those conversion fractions is to let the units cancel. And so that will eventually lead you to where you need to go in order to solve the problems. All right, well, that's it for me. I'll see you in the classroom, and just remember, you got this.